So why Redux? There are countless libraries in the React ecosystem, so why has Redux become so popular? Shopping for a Flux implementation to go with React used to feel like walking into an ice cream shop. There were so many options. They all taste great in their own way and solve some basic problems, but they do so in their own unique ways. Vanilla Flux was the first Flux implementation that was provided by Facebook. However, Redux has easily become the most popular flavor of Flux. And here's some quick evidence. Redux has far more stars than Flux, in fact, over twice as many. Over 40,000 stars for an open source project is pretty impressive. In a short time, Redux has become a mature and popular alternative to Facebook's Flux. And in 2016, Redux's creator, Dan Abramov, joined the React team at Facebook. So why has Redux become so popular? Well, I believe there are 7 things that make it special. First, Redux centralizes all of your application's state in a single store. Unlike Flux alternatives, Redux enforces keeping all state in a single centralized object graph. This makes the app easier to understand and avoids the complexity of handling interactions between multiple stores. It also helps avoid storing the same data more than once. Since there's only one store, you're also less likely to accidentally store the same data in multiple places or to request data that you already have available on the client. As you'll see, setting up Redux requires less boilerplate than Facebook's Flux as well. Your container components are subscribed to the Redux store automatically, so you don't have to wire up event emitters to subscribe to the dispatcher. As you'll see, there's no dispatcher at all. Redux's architecture is friendly to server rendering your React components, commonly referred to as isomorphic or universal JavaScript. And Redux uses an immutable store, which has a number of benefits, including performance, but it also enables interesting features like hot reloading, which means that you can instantly see your changes in your browser without losing client-side state. And time travel debugging, which allows you to step forward and backward through state changes in your code and even replay interactions. It's quite impressive. Finally, Redux is quite small. It has a small API and only weighs about 2K. Now, I just said a lot of nice things about Redux, but nothing is perfect. I loved this tweet by Phil Webb. It's so true. If too much is going on behind the scenes, we complain that there's too much magic going on. And if it requires too much code to get things set up, then we complain about boilerplate. So there's an obvious trade-off at play here. Some people complain that Flux required too much tedious and redundant boilerplate for building real apps. Thankfully, Redux requires less boilerplate than Flux, and it offers more power in the process. The great news is, in my eyes, Redux avoids over-abstracting and becoming magic. Of course, this means you still have to write a lot of what some might consider to be boilerplate with Redux. What's important is to understand that there's no right answer on this continuum, but I do believe that it helps to understand approximately where Redux sits on this line. There are portions of Redux that you might consider magic, but keep in mind that Redux is small enough that it's totally feasible to dip into the source code if you're curious. In this short introductory module, we discussed why Redux is worth learning. We saw that Redux has become React's most popular data management library, and we touched on a number of good reasons why. In the next module, we'll set up our dev environment. We'll use Webpack, Babel, Jest, ESLint, and more to build a powerful React development environment from the ground up. And if you happen to already know these technologies, I'll provide you a finished environment so that you can skip ahead. In the last module, we discussed what makes Redux so compelling. But before we start writing code, let's set up a powerful development I want to begin with the big question that you should ask yourself first. Do I need Redux at all? No tool is perfect for every job. I think it helps to think about complexity on a spectrum. On one end is the simplest tool that requires no setup. And on the other end of the spectrum is a complex, powerful, and scalable tool that requires significant setup. If you're building an ultra-simple application, perhaps all you want to use is plain JavaScript. However, an app doesn't have to get very complex before you realize that adding plain JavaScript gets painful. As you start adding interactivity, forms, logic, and want to create reusable pieces, React becomes very worthwhile. Sure, it's more complex to learn than plain JavaScript, but that quickly pays off. The clear component model, the virtual DOM, synthetic events, and the ability to think about your app in terms of small, pure, reusable components are just a few of the great features that make React so popular and help us manage complexity in our apps. Now, as data flows get more complex, you may find yourself displaying the same data in multiple places. You may have a large number of potential state changes that are hard to manage. You may find it helpful to handle state changes in a single spot for consistency, testability, and heck, your own sanity. At this point, there are two popular options to consider: React's built-in context or React with Redux. As you move to the right on this slide, capabilities increase, but so does complexity. There's no setup time required for you to start writing plain JavaScript, but to handle more complex apps, you have to accept that the initial setup takes some time. I want you to keep this in mind as we set up Redux for the first time. There's quite a few moving pieces to get right, but once we do, we'll have a very powerful and scalable foundation for handling seriously complex applications in a manner that's both testable and maintainable. It will provide us rapid feedback along the way, too. I mentioned React's context and Redux can solve some similar problems, so let me step back and explain how each works and what problem they're trying to solve. Imagine this is your app's React component tree. Each circle represents a React component in your app. The top circle represents your top-level app component, which passes data down to these child components via props. What if these two components need to work with the same data? They're in very different parts of your app, so how can they work with the same data? For example, imagine these components in blue need user data. Each could make an API call to retrieve user data from a database, but that could be wasteful and redundant. And how would they communicate to assure that the user data that they're using stays in sync? There are three popular options to handle this. The first option is to lift state to their common parent. In this case, it means moving the user data all the way up to the top-level component, since that's their only common ancestor. This is annoying, though, because it means that you have to pass data down on props through all these other components. These components didn't need the user's data, you're just passing the data down on props to avoid storing the same data in two spots. We added the user prop to these 6 components merely to pass the data down to the 2 components that need it. This problem is commonly called prop drilling. That said, lifting state does work, and it's a good first step for small and mid-size applications. But on larger apps that need to display the same data in many spots, lifting state becomes tedious and it leads to components with many props that exist merely to pass data down. The second way to solve this problem is to consider React's context. With React's context, you can expose global data and functions from a given React component. To access this global data, you import the context and consume it in your component. So it's not truly global data. You must explicitly import the context to consume it. For example, the top-level component could declare a user context provider. This provider would provide user data and relevant functions to any components that want to consume it. So the 2 components that need the user data can import that user context and thus access the user's information via userContext.consumer. Since context can also expose functions for global usage, the consuming component can also call the createUser function that's actually declared way up here in the top-level component if it's exposed via the user context provider. If you haven't tried context, it's certainly worth a look. It's built into React, it's quite elegant, and it's easy to learn. The third option to consider is Redux. With Redux, there's a centralized store. Think of the store like a local client-side database. This is a single spot where the app's global data is stored. Any component can connect to the Redux store. The Redux store can't be changed directly, though. Instead, any components can dispatch an action, such as createUser. When the action is dispatched, the Redux store is updated to reflect the new data. And any connected components receive this new data from the Redux store and re-render. So does Redux sound useful to you? If so, let's move on and learn about the 3 principles at the foundation of Redux's design. The bottom line is, you can build impressive applications with just React, but Redux can be useful for applications that have complex data flows. If you're writing an app that merely displays static data, then Redux isn't likely to be useful. If you need to handle interactions between 2 components that don't have a parent-child relationship, then Redux offers a clear and elegant solution. When you find 2 disparate components are manipulating the same data, Redux can help. This scenario is often the case when your application has non-hierarchical data. Also, as your application offers an increasing number of actions such as writes, reads, and deletes for complex data structures, Redux's structure and scalability becomes increasingly helpful. The most obvious sign that you'll want something like Redux is if you're utilizing the same data in many places. If your components need to utilize the same data and they don't have a simple parent-child relationship, Redux can help. I like the way Pete Hunt boils all this down. You'll know when you need Redux. If you aren't sure if you need it, then you don't need it. When building a new app, don't automatically reach for Redux. Add Redux when it feels necessary. Here's my suggestion. Do these steps in order. Begin with state that's local to a single component. Just use plain React state. Then lift state to a common parent when more than one component needs the data. If you start feeling pain from lifting state, then try using context or Redux when lifting state isn't scaling well. Each item on this list is more complex but also more scalable, so consider the trade-offs. Redux has three core principles. The first is that your application state is placed in a single immutable store. By immutable, I mean that state can't be changed directly. Having one immutable store aids debugging, supports server rendering, and it makes things like undo and redo easily possible. In Redux, the only way to change state is to emit an action, which describes a user's intent. For example, a user might click the Submit Contact Form button, and that would trigger a Submit Contact Form action. The final principle is that state changes are handled by pure functions. These functions are called reducers. That sounds complicated, but it's not. In Redux, a reducer is just a function that accepts the current state in an action, and it returns a new state. To help provide a kickstart for those who are already familiar with Flux, in the next clip, I'll compare Flux with Redux. You don't have to know Flux to work with Redux, but if you happen to know Flux, that will certainly help you pick up Redux more quickly. If you're not familiar with Flux, that's just fine. Go ahead and skip this clip. Flux was the precursor to Redux, but today Redux is much more popular than Flux. That said, if you're curious about Flux, I cover it in detail in Building Applications with React and Flux. Alright, let's begin our comparison of Flux and Redux by discussing what they have in common. Flux and Redux are two different ways that you can handle state and data flows in your React applications. Both Flux and Redux have the same unidirectional data flow philosophy. Data flows down and actions flow up. So the first similarity is that both Flux and Redux enforce unidirectional data flows. All data flows in one direction. They also both utilize a finite set of actions that define how state can be changed. You define action creators to generate those actions and use constants that are called action types in both as well. They both have the concept of a store that holds state, although Redux typically has a single store while Flux typically has multiple. While these core concepts exist in both, as you're about to see, they differ in a variety of ways. Let's explore how they're different. Redux introduces a few new concepts. Reducers are functions that take the current state in an action and then return a new state. So reducers are pure functions. Let's explore Redux in more detail. Let's look at how actions, reducers, the store, and container components all interact to create unidirectional data flows in Redux. Let's consider an example to understand this flow. An action describes a user's intent. It's an object with a type property and some data. The data portion can be whatever shape you like. The only requirement is that an action has a type property. If you've worked with Flux, then this should look familiar. This concept doesn't change in Redux. Here's an action for rating a course. Imagine that you were rating my course on a scale of 1 to 5. Let's just say you rated it a 5. Come on, be my friend. You know you want to. Okay, anyway, if you did click to rate it as a 5-star course, then this is the action that would be produced. This data portion on the right can be whatever you like. You could pass multiple separate pieces of data here or just one or more separate objects. This action will ultimately be handled by a reducer. A reducer is a fancy name for a function that returns new state based on the action that you pass it. So as you can see, the reducer receives the current state in an action, and then it returns a new state. Reducers typically contain a switch statement that checks the type of action passed. This determines what new state should be returned. Once this new state is returned from a reducer, the store is updated. React re-renders any components that are utilizing the data. Your React components are connected to the store using a Redux-related library called React-Redux. We'll wire all this together in the next module. In this short module, we took a quick look at Redux at a high level. We discussed the various scenarios where Redux is useful, which basically summed up to, if you need it, you'll know it. I covered the 3 core design principles of Redux, that state is immutable, actions trigger changes, and reducers return updated state. We saw how Flux and Redux are similar, but they differ in key ways, particularly around Redux's lack of a dispatcher, its immutable single store, and the store subscription approach. We wrapped up by reviewing a simple example of unidirectional flow. Now that you're generally familiar with actions, stores, and reducers, in the next module, we'll explore these core concepts in more detail. We've discussed Redux's core concepts in the previous modules, but we don't know enough yet to start writing code, so now's the time to dive deeper into the core pieces of Redux. In this module, we'll look at actions, the Redux store. We'll discuss immutability in detail, since you need to understand how to handle this concept in JavaScript before you write reducers. And we'll close out by discussing how Redux handles state updates with reducers. Alright, let's start by exploring actions further. In Redux, the events happening in the application are called actions. Actions are just plain objects containing a description of an event. So here's the plain object. This is the action. An action must have a type property. The rest of its shape is up to you. Here I'm passing some data under a property called rating. This could be a complex object, a simple number, a boolean, or really any value that's serializable. The only thing that you shouldn't try passing around in your actions are things that won't serialize to JSON, like functions or promises. Actions are typically created by convenience functions that are called action creators. Here's an action creator called rateCourse. Typically, the action creator has the same name as the action's type. Action creators are considered convenience functions because they're not required, but I recommend following this simple convention. By using these action creators to create your actions, the spot where you dispatch the action doesn't need to know about the action creator's structure. The app that we're creating will work with course data, so it will have actions like load course, create course, and delete course. When actions are dispatched, it ultimately affects what data is in the store. So let's discuss the store next. In Redux, you create a store by calling createStore in your app's entry point. You pass the createStore function to your reducer function. The Redux store honors the single responsibility principle because the store simply stores the data, while reducers, which we'll discuss in a moment, handle state changes. You might be concerned that there's only one store in Redux, but this is a key feature. Having a single source of truth makes the app easier to manage and understand. The Redux Store API is quite simple. The store can dispatch an action, subscribe to a listener, return its current state, and replace a reducer. This last feature is useful to support hot reloading. The most interesting omission here is that there's no API for changing data in the store. Now, that's a good thing. It means that the only way that you can change the store is by dispatching an action. That's why I'm showing the padlock icon on the store. You can't change it directly. The store doesn't actually handle the actions that you dispatch. As you'll see in a moment, actions are handled by reducers. To understand reducers, we need to discuss immutability first. So let's do that in the next few clips. Immutability is a fundamental concept in Redux. So in case you're not familiar with working with immutable data, let's discuss what it is, why it's useful, and how to handle immutability in JavaScript. You might be wondering how you can build an application that doesn't mutate state. I mean, if I can't mutate state, doesn't that mean that no data can change? Not at all. It just means that instead of changing your state object, you must return a new object that represents your application's new state. It's worth noting that some types in JavaScript are immutable already, such as numbers, string, boolean, undefined, and null. In other words, every time you change the value of one of these types, a new copy is created. Mutable JavaScript types are things like objects, arrays, and functions. To help understand immutability, let's consider an example. Imagine that our app's state holds my name and my role. In a traditional app, if I wanted to change state, I'd assign a new value to the property that I want to change. So here I'm mutating state because I'm updating an existing object to have a new value for role. Let's contrast this approach with the immutable approach to updating state. Here you can see that I'm not mutating state. Instead, I'm returning an entirely new object. This is important because Redux depends on immutable state to improve performance. We'll get to why that's a big win in a moment. First, you might be thinking, yuck, do I have to build a new copy of state by hand every time I want to change it? Thankfully, no. That would be very impractical on an object with many properties. Let's look at some easy ways to create copies of objects in JavaScript. If you haven't dealt with immutability before, you might be wondering how to easily create a copy of an existing object. There are multiple ways to get this done using plain JavaScript, including object assign, the spread operator, and immutable friendly array methods like map, filter, and reduce. Let's briefly look at each. Object assign creates a new object but allows us to specify existing objects as a template. The first parameter is the target, and then it accepts as many source objects as you want. Let's look at an example. Here I'm saying change it out. On the right is shallow copy objects, but I'm changing a draft state here. If you want to use these methods, you must clone these to handle immutability, but object assign, the spread operator, and immutable friendly array functions like map, filter, and reduce. Now that we have a good foundational understanding of immutability, we're ready to discuss how data changes are handled in Redux using reducers. To change the store, you dispatch an action that is ultimately handled by a reducer. A reducer is actually quite simple. It's a function that takes state in an action and returns new state. That's it. You can think of a reducer like a meat grinder. With a meat grinder, you put in some ingredients and turn the handle. The results, well, they come out the other side. In the same way, with reducers, you pass in some ingredients, in this case, the current state and an action, and it returns new state. So if you don't like the meat grinder metaphor, let's try one that's a little more cuddly. Reducers sound scary at first, but they're really like a fluffy bunny. They're so approachable, so simple, and so tasty. Wait, I don't eat rabbits, I swear. Never mind. Here's a reducer that's handling incrementing a counter. Reducer functions just look at the action passed and return a new copy of state. So, for example, if the action passed was increment counter, then it would increment the counter and return the new state. The reducer knew what state needed to be changed by looking at the action passed, and it updated the state accordingly. However, there's something wrong with my example. I'm mutating state right here. As we've discussed, in Redux, state is immutable, so in other words, it can't be changed. Let's update this example to return a new copy of state instead. This example does not mutate state. I'm using object.spread to create a new copy of state. Let's dissect this line. Here I'm saying create a new object by copying the existing state. I'm using the spread operator. On that new object, set the counter property to the current value plus 1. So this statement copies the existing state object, but the copy has the counter property incremented by 1. Remember that reducers must be pure functions. This means that they should produce no side effects. You know you have a pure function if calling it with the same set of arguments always returns the same value. Because reducers are supposed to be pure functions, there are 3 things that you should never do in a reducer. You should never mutate arguments. You should never perform side effects like API calls or routing transitions. And you should never call non-pure functions. A reducer's return value should depend solely on the values of its parameters, and it should call no other non-pure functions, such as date.now or math.random. This way, the reducer stays pure. It simply takes the current state and an action and returns new state. So no mutations or side effects should occur. It's just a pure, predictable result. Remember, instead of mutating state, you return a copy of what was passed in, and Redux will use that to create the new store state. I mentioned earlier that you typically only have one store in Redux. So while you might think that having one store would be limiting and lead to huge monolithic stores that are hard to manage, in practice, it's not a problem. You can manage slices of your state changes through multiple reducers in Redux. When a store is created, Redux calls the reducers and uses their return values as initial state. But you might wonder, if we have multiple reducers, which one is called when an action is dispatched? Well, the answer is all of them. All reducers get called when an action is dispatched. The switch statement inside each reducer looks at the action type to determine if it has anything to do. This is why all reducers should return the untouched state as the default. This way, if no case matches the action type passed, the existing state is returned. So for example, if I dispatch the delete course action and my app has 3 reducers, one for courses, one for authors, and one that handles loading status, all 3 of these reducers will be called. But only the reducer that actually handles the delete course action type will do anything. The others will simply return the state that was passed to them. Each reducer only handles its slice of state. In fact, each reducer is only passed its slice of state, so it can only access the portion of state that it manages. So while there's only a single store for Redux, creating multiple reducers allows you to handle changes to different pieces of the store in isolation. This makes state changes easy to understand, and it avoids issues with side effects. Just remember, all the reducers together form the complete picture of what's in the store. One final note on reducers. You might wonder if there's always a one-to-one mapping between reducers and actions. Nope, the Redux docs recommend using reducer composition. This means a given action can be handled by more than one reducer. Bottom line, remember, each action can be handled by one or more reducers. And each reducer can handle one or more actions. Alright, we've discussed actions, the store, and reducers. Let's summarize what we covered in this module. Let's wrap up with a quick summary. In this module, we saw actions and action creators. Actions represent a user's intent, like create course or empty cart. Each action must have a type property, otherwise its shape can be whatever you like. We saw that the Redux store has a simple API with only 4 functions: dispatch, subscribe, get state, and replace reducer. We learned what immutability is and how to handle it by simply returning a new copy of state. We saw how reducers are pure functions, which means that they have no side effects. For a given input, they'll always return the same output. Most apps will have multiple reducers. This way, each reducer can handle a separate slice of the store. Remember that reducers are like a meat grinder. They take state and an action, and they return an updated state. No, wait, they're like a bunny. They're simple and approachable. Like the rest of Redux, they're just plain old JavaScript. Nothing fancy. It's about time that we put all this knowledge to use and start writing some code. But before we do, there's one important piece missing. How do we connect our React components to the Redux store? We'll see how to do that in the next short module. We've explored nearly all the Redux pieces that we're going to use in this course. But the one obvious remaining question is, how do I connect my React components to Redux? The great news is, Redux pulls this off in an elegant way. So in this module, we'll begin by quickly reviewing the difference between container and presentation components. Then we'll check out React-Redux, the Redux companion library that will connect our React components to the Redux store. You'll see how the provider component wraps the application so that the Redux store is available, and you'll see how to use the connect function to connect React components to the store and specify what properties and actions you'd like to attach to your component. We'll wrap up our discussion with a summary style inspired by the great Kathy Sierra that I call a chat with Redux. This will help you understand Redux by thinking about each of the pieces as different people that are having a conversation. The rest of the course is almost exclusively writing code, so let's wrap up these final key concepts. In a previous module, we talked about container and presentational components, also known as smart and dumb components. To understand React-Redux, it's important to understand these two types of React components. Redux's documentation uses the terms container and presentational components, but I personally prefer to call these smart and dumb components, since containers contain all the smarts that are necessary to support the dumb presentational components below. So let's contrast container and presentational components. Container components are focused on how things work. They handle data and state so that all the child components below can simply receive the data and actions they need via props. That's why they're called presentational components. They're focused on how things look. Container components are the only components in your system that are aware of Redux at all. This is a great thing because it means your child components are simply presentational components. They just receive data and actions via props and contain markup. Container components subscribe to Redux state, while presentational components read data from props. In a similar way, container components actually dispatch Redux actions, while presentational components fire off actions by invoking the callbacks that are passed down to them via props. So in this way, a presentational component isn't tied to a specific behavior. Its behavior is passed down from a container component via props. With this difference established, let's discuss how to connect our React components to Redux. So what actually connects your React components to Redux? Well, that's what the React-Redux library is for. We looked at the flow of Redux on a previous slide. React-Redux handles this final piece. It connects your React container components to Redux. React-Redux is a companion library for Redux. It's a separate library because Redux isn't merely useful for React. Since Redux is simply a way to handle state, you can use Redux with other libraries. So you could use Redux with Angular, Vue, Ember, jQuery, or even vanilla JavaScript. That said, Redux was initially created as an alternative to Facebook's Flux, and most people today are using Redux with React. So in this course, I'm going to assume that you're using Redux with React. So we will use the React-Redux library to connect our React components to the Redux store. React-Redux ties your React components together to Redux, and it consists of two core items, the provider component and the connect function. The provider component is utilized at your app's root. It wraps your entire application. This is how the provider component attaches your app to the Redux store. Connect is a function provided by React-Redux that, not surprisingly, connects your React components to the Redux store. Let's take a look at each of these in more detail. The provider component attaches your app to the Redux store. You declare the provider once in your app's entry point. So you use the provider component to wrap your app's top-level component. If you're curious how this works, the provider component uses React's context to pull this off. So the provider component makes the store available to all child components without you having to pass the store down explicitly. You only need to use this once in your root component. Now let's discuss the second piece of React Redux, which is the connect function. The second important piece of React Redux is the connect function. This function wraps a component so it's connected to the Redux store. With this function, we can declare what parts of the store we'd like attached to our component as props. We declare what actions we want to expose on props as well. Let's contrast this approach with Flux. In Flux, you wire your components to the store and component will mount, and you have to do this manually. When your components are removed from the page, you need to remove the change listener that you set up, and component will unmount. Required more Redux with React, you use a function called connect. This function connects your React component to the store, so the function is certainly named well. You pass connect two arguments, map state to props and map dispatch to props. The first argument specifies what state you want to pass to your component on props, and the second argument specifies what actions you want to pass to your component on props. I want to point out some benefits to Redux's approach over plain Flux. First, you don't need to write boilerplate code to subscribe and unsubscribe from your store. The connect function that comes with React Redux does that for you. With Redux's style, you can clearly declare the subset of state that you want to expose to your container component. In traditional Flux, when you wire up a change handler to a store, the entire store's data is exposed. And finally, the previous point is important because by declaring carefully what specific data you need, Redux. The connect function accepts two parameters. Both are typically functions, and both of these parameters are optional. The first parameter is map state to props. This function is useful for defining what part of the Redux store you want to expose as props on your component. When you define this function, the component will subscribe to the Redux store updates, and anytime it updates, map state to props will be called. This function returns an object. Each property on the object that you define will become a property on your container component. So in summary, the map state to props argument determines what state is available on your container component. This is a logical place to filter or otherwise transform your state so that it's most conveniently shaped and sorted for your component's use. Let's consider a simple example. If you're building a simple app, you may have only one reducer and one container component. In that case, you just want to pass down all of your state. But as your app grows, you'll likely want to create multiple components to manage different pages or sections of your app, and you'll likely want to create different reducers to handle different slices of your store. This is an example of a simple map state to props function that makes all of your state accessible to the component via props. With this setup, I could say this.props.appState within my component to access any state that's handled by my appState reducer. Now, what if I only want to expose part of my store's state in the component? Then I can specify the specific pieces of state that I want to expose via props here. Each object key will become a prop on my component. Being more specific is a win too because it helps with performance. Remember, React components re-render anytime that props change, so you should only pass in props that your component needs. This way, each connected component only re-renders when the props that it needs have changed. Module. So if you're doing something expensive in there, you'll want to use a library like reselect for memoizing. Same principle for encrypted operator that these are expensive. Alright. Similar to map state to props. The different ways of passing actions to components use bind action create. This means you can call dispatch set the action. This approach isn't ideal. Explicitly. One by one, I wrap each action creator, but as you can under this dot action creators, and it will wrap the actions passed to it. Action creators wrap. A fourth option is to declare map dispatch to props as an object instead of as a function. In this example, assume that load courses is an action creator. When you declare map dispatch to props as an object, Redux's connect will automatically wrap each action creator in dispatch for you. I like this approach because it's quite concise. Here are the 4 patterns side by side. I tend to prefer option 4 since it's the most concise. We'll go at first to think of different React says, hey, course action. Someone just clicked this Save Course button. The action says, thanks React. I will dispatch an action so that reducers that care can update state. The reducer says, thanks action. I see that you passed me the current state and the action to perform. I'll make a new copy of the state and return it. The Redux store says, thank you for updating the state, reducer. I'll make sure that all connected components are aware. React-Redux says, whoa, hey, thanks for that new data, Mr. Store. I'll now intelligently determine if I should tell React about this change so that it only has to bother with updating the UI when it's necessary. Finally, React goes, ooh, shiny new data that's been passed down via props from the store. I'll update the UI to reflect this. And that's how data flows through Redux in a unidirectional manner. We've covered a lot of ground, so let's important container style give what they need. We'll wrap our app and the provider container components to the Redux store. That map state to prop layer was on our dispatch want to explain ways, and now no geeky ninja JavaScript deal with this morning and